Welcome everyone, myself Tarun Verma. This time I am here with an interesting chapter of class 9 science, that is motion. Actually, this is your first chapter in physics if you divide all chapters in physics, chemistry and biology. Here I have divided the chapters into two major parts as you can see on your screen. First is introductory part in which I will explain motion, its type, speed and velocity, average speed and average velocity, acceleration and its example, and some graphs. In the second, we will discuss about derivation of all three equations of motion and circular motion. Now let us talk about the motion. If a body is covering, if a body is changing, if a body is changing its position with respect to time, then it is said to be motion. Suppose motion of a bicycle, motion of a car, motion of a train, bullet train, motion of a ball, jumping ball, bouncing ball, whatever. Or in microscopic sense, you can say if an amoeba or paramecium is covering several millimeters in hours or in a day, then this is also motion. But if a body is not changing its position with respect to time, then it is said to be in rest. Means the body is stationary, not changing its position at all. The time is going on. Now, let us think about the types of motion. There are majorly two types of motion: uniform motion and non-uniform motion. If a body travels equal distances in equal interval of time, it is said to be in uniform motion. But if a body travels unequal distances in equal interval of time, it is said to be in non-uniform motion. As you can see, I have underlined it equal interval of time. In both of the cases, here is a common word, equal interval of time. In uniform motion, the body is covering equal distances in equal interval of time, and in non-uniform, the body is covering unequal distances in equal interval of time. Suppose if a biker covers 3 kilometers in every 5 minutes, in the next 5 minutes, he again covers 3 kilometers, and in the next 5 minutes, he again covers the same. Then this is said to be uniform motion. But the same biker, if he covers 3 kilometers in first 5 minutes, 2.5 kilometers in the next 5 minutes, and 2 kilometers in the next 5 minutes, then this will be the type of non-uniform motion, because in equal time intervals he is covering unequal distances. Now let us deal with simple examples as movement of clock's hand, because here each needle is covering equal distances in equal time interval. Each needle has the specific different time intervals to cover the same distances. As if we talk about the second hand, the second hand covers one round in every 60 minutes. In every 60 seconds, that is 1 minute. Therefore, the motion is uniform and the same nature is repeated again and again. Now, if we talk about the pendulum clocks, then its pendulum covers to and fro motion in the same interval of time, means in one oscillation it takes the same time. If we talk about the motion of a bouncing ball or motion of asteroid, these are non-uniform because they cover unequal distances in equal time intervals. Scalars and vectors. Scalar quantities has only magnitude, while vector quantities have magnitude and direction. To show vector quantities, we use an arrow as displacement vector, acceleration, moment, force. These are the vector quantities, but length, speed, mass, pressure, temperature, energy, work, these are scalar quantities. Why? Suppose if you are talking about temperature, then temperature can't be measured in a specific direction. If you are measuring body temperature, you cannot say that you are measuring the temperature in the east, temperature in the west. But if you are pulling or pushing an object, it means you are applying a force on the object. It means that the force will be applied in a particular direction, because on applying your force, the body will move or tend to move in a particular direction. There will be definitely a direction of your application of force. Now let us talk about distance versus displacement. Distance is scalar quantity while displacement is vector quantities. Keep in mind. Now distance is the amount of space between 2 points, while displacement is the shortest path covered by the body. SI unit of distance is meter, while and the same is for displacement. Distance is the actual path length covered by a body or an object, while displacement is the difference between the final point and initial point. Let us understand it with an example. Distance is a scalar quantity, whereas displacement is a vector quantity. Actually, distance is the actual path length, as we have read in the previous slide. Distance is the actual path length covered by a body or an object. We can see that if a ribbon is put curved, then the distance will be the measurement on straightening it. The measurement of the length of the ribbon on straightening it will be the distance, that is the actual path length, while the displacement is the shortest way. If we are talking about a circular object, if a point or an object is moving from a specific point and after a circular round it covers the same point, then the distance will be its circumference, while displacement will be 0. Now let us talk about speed, which is a scalar quantity. So it only depends on magnitude. We use odometer. You have seen in your bikes and cars, you have odometer to measure speed, the rate at which an object moves, known as speed. Speed depends on distance traveled and the time it takes to travel that distance. Now, velocity if the same speed is given a particular direction, means, as you know, velocity is a vector quantity, because velocity always has a direction with its magnitude. Then don't confuse this with speed, because velocity and speed are different things. Speed cannot be negative, but velocity can be negative depending on the direction. Now let us think about some examples. Velocity must always include a direction. It is denoted by vector v. For vector sign, we put an arrow above the quantity. An airplane's velocity might be 600 km per hour south. Then the south direction here reveals us that this is the example of vector quantity. It means it is velocity. 30 mile per hour or 30 meter per second east. As you can see here, the car is moving 30 mile per hour east. Then this is the example of speed, and the same is here, 60 mile per hour northwest, 60 mile per hour east. These are all examples are given with directions and magnitude. Therefore these are velocities. Now acceleration actually acceleration is the measurement of the rate of change of speed with respect to time. Means acceleration measures how much you are changing your speed with unit time or per unit time. Acceleration is a vector quantity, then you can show it like vector A is equals to delta V upon delta T. This triangular sign denotes the small change in the quantity, which can also be written as V2 minus V1 upon T2 minus T1, where V2 is the final speed, V1 is initial speed, T2 is the final time, and T1 is initial time. Now average velocity. Average velocity is the ratio of total displacement to the total time taken. Here is given the formula of average velocity, total displacement upon total time taken. Now the next formula can be given as initial velocity plus final velocity by 2, where u is initial velocity and v is final velocity. Then we can write mathematically u plus v upon 2. SI unit of velocity is meter per second, so the same unit is here for average velocity, meter per second. Speed and velocity, in both we have the same magnitude. If we are talking about the straight line, then both have the same units, meter per second, given here. Now average speed. To measure average speed, we divide total distance traveled with the total time taken. Hence we can say it is the ratio of total distance to the total time taken, and the formula is given here. Average speed is equal to total distance traveled upon total time taken. Now here is given an example. If a car changes its speed from 10 meter per second to 20 meter per second in just 5 seconds, then car is accelerating from 10 meter to 20 meter per second. You have your initial velocity u and final velocity v, and the time t is equal to 5 seconds. Then average velocity is equal to u plus v by 2, as we have seen in the previous slide. 20 plus 10 by 2 means 30 by 2. It means 15 meter per second, or you can write it like 15 meter per second. Thank you. The other parts will be covered in part 2.